All right, so today we are introducing descriptive statistics. There's a couple of terms to go over first. A categorical variable is one that it's categories, right? So basically what that means is you're splitting things into things like color, gender, brand, make, model, things of that nature. So it's not really a numerical thing, it's more of a conceptual thing. In terms of quantitative, right, that's the opposite. So that's a numerical value. So someone's height, someone's weight, how many people are in a room, things like that. When we talk about discrete variables, these are things that only come out in terms of exact numbers. So this would again be like the number of people in a room. You can't have any sort of decimal answers, basically, usually. So for continuous variables, these are things that can be presented over a range. So, for example, if you're looking at like the height of a group of people, you may want to group them by range of height instead of specific height, because maybe you have some people that are 5.5 feet, maybe they're 5'6 1/4, and you kind of want to group that together. So you would treat it as a continuous variable instead of a discrete. Let's look at some examples. So if we're looking at the number of goals scored each week by a basketball team, right, that is a specific number, so that is going to be a discrete variable. If we're looking at the heights of members of a football team, remember, you might have people that are very close but not exactly the same height. So we would probably want to treat this as a range, which would make it continuous. All right, so the most popular radio station. So the actual radio station itself is not a numerical value. So this would be a categorical variable. All right, so here's some examples for you to do. So the next thing we're going to look at is different ways of organizing our information. So a tally or a frequency table, right? That's where we're just sort of counting up and writing down the number of each that show up. For ways of doing that, the most common that you'll see are usually dot plots and stem plots, which is also called stem and leaf. So in a dot plot, we're literally just going to write the number that we counted and then put the number of times that one showed up. So if you look at the tally table to the left, it says we counted the number 3 2 times. So next to 3, I put 2 dots. Right? I counted the number 4 9 times, and I put 9 dots. For a stem and leaf, we're just going to list out the numbers as they appear. The key being that the stem column is the tens digit and the leaf column is the ones digit. So this, you could just rewrite it as 9, right? 0, 9. This tells me that I got a 17 and I got an 11. When we're describing the distribution, basically we're going to look at the shape of the curve that is made when you sort of connect the tops of each bar, or in the frequency distribution, the dots, or even the number of things in the row of the stem and leaf. So if you make a nice, sweet curve where the top of the curve is in the middle, that is a normal distribution. This is telling us that the mean, which is the average, and the median are both right in the middle. This is also called symmetrical distribution because each side is the same, they match, right? So if you notice that the curve is skewed to one side or the other, then we're going to basically say that it is either negatively skewed if the left side looks stretched out, or positively skewed if the right side is stretched out. Last thing on this, outliers are numbers that don't show up very often, so maybe the number only appears once, and it's usually something that is either much higher or much lower than the other numbers in the list. This is what tends to cause our curve to be skewed. So if we look at this example, what is the variable in this investigation? Well, we looked at the number of phone calls made by a sample of 50 15-year-olds. So the variable that we were counting is the number of phone calls. All right, so it says what percentage of 15-year-olds did not make any phone calls? So if we go back to the previous picture, we can see that 0 phone calls has 5 dots. We also know that there were 50 total students. So 5 students were questions, gave us the answer of 0 out of 50, which is 10%. All right, so if we're describing our distribution, that means we need to go back and look at whether or not the curve was skewed. So if we notice, the peak of the curve is closer to the front half than the last, right? And so the sort of downward sloped portion is way stretched out compared to the rest. So this is going to be a positive skew. And finally, how would we describe the data value 11? So we go back. The 11 is way off to the side. It only shows up once, and it's the highest one, right? It's all by itself. So that would be our outlier. So here's an example you can try on your own. Okay, so let's look back at stem and leaf plots. As I mentioned before, the stem is the tens digit. The leaf is the ones digit. If they are just put together by rows, then it's a standard stem and leaf plot. Ordered stem and leaf literally just means they put the numbers in order. And the only reason, or the main reason to do this rather, is to make it easier to read. We also have column graphs. And so for a frequency table, notice this is a range. So what they're saying is from 0 to 9, there is one thing. So they wrote a 0, they wrote a 10, which is slightly less than 9, and they made the bar go up 1. Then between 10 and 19, it's 5. So again, there's 5, etc., etc., etc. So if we're looking at the stem and leaf plot, we need the minimum value. So again, that's going to be this guy. So 0, 2 is the same as 2. But the maximum value is down here. So it says find the number that are greater than 25. So again, this is why it's helpful to have them in order. So 25 is here. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 terms greater than 25. number of data with the value of at least 40. So again, 40 is right here. So at least would mean 40 or more. So 1, 2, 3, 4, 5 terms. Percentage of data that is less than 15. So there is no 15 on our list, but it would basically be between those two. Right? So it looks like we have 6 terms that are less than 15. And our total, if we count it up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Hey, teachers and staff, at this time we are going
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So again, if we take 6 out of 35, convert that into a percentage, it should be about 17%. And finally, how would we describe the distribution of this data? Again, draw your curve if you can't see it. We notice the peak of the curve is closer to the top than the bottom, which means that the bottom numbers see the biggest stretch. Bottom numbers are bigger, so this would be a positive skew. All right, that is the last example for the day. I will see you in class.